Okay, so now we're getting to the third way that we can solve a quadratic. And when we actually talk about this, I guess really a lot of it is trinomial quadratics, meaning that there's a middle term. If there's no middle term, you can use special factoring, or you can just add across and then square root both sides. But so a trinomial, meaning there's a third part or a middle term, we can solve using completing the square. Completing the square is really it's a pretty nice way, and it scares a lot of kids. But if you actually get good at it, it's really easy. I had a student in college that would do this on every single quadratic, every single one, decimals, fractions, it didn't matter what. She would use completing the square every single time, and very efficient at it, and it's for her it was way easier than the quadratic formula, which I gotta agree with on some things that it is a little bit easier, which is pretty neat. Believe it or not, it breaks it down for you a little bit better than a quadratic formula, so that's an advantage. Again, solving quadratics using completing the square, and so we're going to go ahead and do this solving a quadratic a third way. Okay, so solving a quadratic using completing the square, you first got to know your steps of completing the square. We can ignore all this stuff back here in the back side here, which is the +4 and the equals 1. It can ignore that. It will come into play, but for right now, it doesn't. So the first part is, in you completing the square, is you're going to go ahead and draw parentheses around the x squared and the x term. And then we need to make this a leading coefficient of 1. So how do we do that? Well, we're going to factor out a 2. So that means I'm going to pull a 2 out in front, and that's going to make this x squared minus 10x. Okay, I'm going to put a little space here. And this 4 here, I'm going to go ahead and move to the other side, which makes that equal to -3. The reason why we leave the space is we're going to go ahead and complete the square. Now, how did I get 10x there, -10x? I divided that by 2. When I factored out the 2, I divided, and I put that 2 out in front, I divided each of this. I divided that by 2, and divided the -20 by 2. So that's going to give me x squared minus 10x equals -3. Now the next step, and this is actually not a bad step at all also, is we need to complete the square. We need to figure out what makes this a perfect square. So it's always half this middle term here of -10. It's always that it has to do with the square, and I'll draw that on the next page to show you one of the pages here. So anyhow, half of -10 is -5. If you square that, that's what's going to make it a perfect square. So we're going to add 25, and we're going to put a -25 in there also. I don't know if I can draw this in there very well. And so the value that we actually added, which is, of course, 0. We did not change anything. And that's important. Whatever you do when you're solving equations is you're not trying to change the solution. You're finding the solution, and so whatever you do cannot change your final solution. So when I add 0, not going to be a problem. If I multiply by 1, won't be a problem, because those things will not change the solution. Okay. So now the positive 25 is going to stay inside. The -25 has got to go out. It's going to go outside the parentheses. Okay, it's going to jump out there. But as we talk about distribution, there's actually 2 -25s, because the 2 out in front means there's 2 -25s. Hence, that's going to give me 2x squared minus 10x. The plus 25 is going to stay. And the -25, but there's 2 of them, is going to make -50 equals -3. Okay? Okay, so here's the problem rewritten again. And you're thinking, well, boy, this is really nice. What good have I done? Well, the thing that's really nice about this is x squared minus 10x plus 25 is a perfect square, meaning that it is factors to be x minus 5 times x minus 5. How do I know that? Well, you have x minus 5, and the reason why is because what two numbers multiply to be 25 and combine to be -10? It's -5 and -5. Hence, this is going to be x minus 5 squared. If I clean this up, I put the -50 to the other side of my equation. That's going to make it equal to positive 47 over here. So right now I only have a single square, which is going to make it nice. So I'm going to go ahead and divide by a 2. And so now I have x minus 5 squared equals 47 halves. Oh, which is something. I mean, it's 23.5. So I mean, you could break it down like that, or you could leave it as 47 halves. It doesn't matter, but it's very nice. Okay, so I've divided that across, and it made it 23.5. And now I only have really 2 more steps to do, and it's pretty quick. Is that I'm going to get rid of this square by square rooting. So I'm going to square root both sides. Now, there's 2 solutions when you solve a quadratic. 2. Let's count them. 1, 2. And the way that you're going to get 2 solutions here is whenever you square root both sides, you must introduce a plus or a minus. Okay, so it's 23.5. And so that's going to give me x minus 5 equals that. I'm going to go one step further, and it's going to be x equals 5 plus or minus square root of 23.5. Now, a lot of people probably don't solve using completion of the square. I told you about my student that did that every single problem, and she was really good at it. I mean, she was way quicker at completing the square than I was to do the quadratic formula. Well, maybe not quite, but she was pretty close. So she was very good at this, and for her, it was huge. It made every problem pretty easy for her. She could care less. Like I said, didn't matter fraction or decimal. She did that really well. Alright, so now let's go ahead and have you do this next problem. Alright, so this is the next problem, 3x squared minus 12x minus 6. So I'm going to go ahead and stop the video right now, and you're going to go ahead and take a few moments and attempt this yourself. Or you can stop the video if you're watching this at home, and then I will show a couple of main steps and give you the solution. I have to say, man, isn't this a nice marker? Really, this blue, it's a brilliant blue. Okay, anyhow, so we pulled out the 3, and then once we've done that, so when you divide 12 by 3, that gives you the negative 4 here that's right there. And then you half of negative 4, which is 2, square that. That's why you get the 4 and negative 4. So just be cautious of that. Now, what I've done here is I've gone and taken the negative 4 that was up here, and I've brought it out. But when I brought it out, there's actually 3 of them. That's what this 3 out here tells me. There's 3 negative 4s, okay? So there's 3 negative 4s, hence that gives me the value of negative 12. So 3 times negative 4 is negative 12. So that's why that's negative 12 out there. At this point, I can quickly factor, which is going to be 3x minus 2, and it's x minus 2 times x minus 2, or x minus 2 squared, and this is going to equal 18. And the reason why it's equal to 18 over there is, of course, I took the negative 12 and the negative 6 and combined that and moved it to the other side. So that's why that's equivalent to that. So now you're going to see the solution on the next page here. So again, hopefully you've gotten this far. The toughest part is just making sure that you don't forget to apply the 3 to the negative 4s that's coming outside there. Okay? Alright, here we go. Okay, so you get to the point where you have 3 and then x minus 2 squared and equals 18. So you're going to divide by the 3, so you isolate the x minus 2 squared, and then you square root both sides, and don't forget, that's how you get the 2 solutions. You get a plus or minus when you square root both sides. And once you get this isolate x, you get x equals 2 plus or minus the square root of 6. And just for the fun of it, we're going to take and give you a nice, what a wonderful lightning bolt coming out of that cloud. And I hope you enjoy this. Again, completing the square is not too bad. And the next slide here is going to tell you actually why completing the square works as it is. So what we're doing, if you've done factoring tiles, you probably have a really good idea about this. So, but again, the next slide is going to give you that idea. And in a factoring tile, you have this. That's the x squared. Okay, and so then we'll call these x's. Alright, and then this is like another x. Okay, and so right now you have on the side length, this is x, and these have a side length of 1, 1, 1, 1. So that's x plus 4 times x plus 4 right now. But you're missing space in order to make a perfect square here. You have all this space right here. Now you're going to put in, And this is what we do, is we complete the square. Hence, we complete this shaded region right here. We make it so that this is no longer empty. Okay, so what we have is there's 1 spot, 2 spots, 3 spots, 4 spots, 5 spots, 6 spots, 7, all the way out, and that's going to give us actually 16 spots there. Okay, hey, that looks like my first year. That's an inside joke. Okay, so a lot of spots. There's 16 dots there representing the 16 little spots that we had to fill in. And it was, again, we could figure that out because it was, in this problem, it was x squared plus 8x, because we had 8 of these long blue things here, and then we needed half, because half was on one side, half was on the other side. And if you multiply those, that's why you get 16, because 4 times 4 is 16, and that's what's in this space here. So that's what completing the square looks like, and it almost actually looks like a flag, but it really is completing or filling in the missing area. And that is completing the square, which is part 3 that we have now concluded. And the next one is going to be, the next one will be using the quadratic formula. Now, the quadratic formula is quite nice also. Alright, so completing the square. Done.